All right, intro.
Okay, yes, we are recording.
Yeah, Jim or Walter might be able to, to lower that a little bit.
All right, so welcome everybody. This is the monthly meeting for the Robotic Society of Southern California. Today we have two great talks. The first one, Alan is gonna give us
That's a little bit, so I'm in darkness now.
yeah, is there like a adjustment?
I think so. Okay. Yeah, let's try there. All right.
Yeah, so Alan, gonna give us a talk on his abilities. And then after that, Jim gonna talk about his, struggles and tribulations with, his IMU. His, Drusilla. Should be a good talk. If, there's no other questions.
All right. All right. Good morning, everyone. Here's a basic outline of what I want to share with you guys today. After an introduction, I want to focus the majority of our time on amazing tool that Brian Erickson had mentioned for the past couple of months called Distrobox, and an accompanying user interface called BoxBuddy that makes using it really, really easy. And after a quick survey of available distros, once you're freed from being tied to a specific distro, I'd like to show you one that really caught my eye, Fedora Silverblue, which is an immutable or atomic desktop. So we'll talk about how that's important. And then how I ended up in Arch. First, a quick update on some of the previous projects that I've talked about. For the go-to reverse engineering, I gave a talk last month. What I had shown was twice as complicated as what I introduced you to a couple months prior. And then one of the guys that were on our call named Konstantin, he really took the ball and ran with it. He's kept at it and discovered not only and defeated the rest of the reverse engineering checks in the executables, but then the second or third level after that, things that they implemented to prevent reverse engineering and hacking it. And as I had mentioned last month, I totally understand that. It's a commercial product. They're selling to the military now, or at least the Chinese and Ukrainian military. And with the G1, the humanoid, as a consumer of these devices, you want reasonable assurances that they can't be hacked. So as he got further into it, and I was not trying to keep up, he's left me in the dust, but to understand, the reverse engineering checks were some type of commercial library that they purchased. It's too clever to have come up really on their own. They're mostly a hardware company, and they're super talented. I'm not saying they're not talented, but that's not one of their strengths. And then everything after that, I think they were partnering up with Chinese intelligence or Chinese military, because the anti-hacking measures that were in place were really, really clever. So as of this weekend, he has a cracked version of the executable for the new version of the software, including the sexy new AI walk. And there's no chance I'll be able to keep up with that. And I'm just happy as can be that he is as smart as he is and was able to figure it out. The go-to head that I brought here, it's hardware complete. I'm very happy with that. But it turns out the math that I have for moving the head assumes a cylindrical arrangement for the base and the platform. In other words, the radius of the base and the radius of the platform are the same. They're the same radius or diameter. And mine has a smaller platform diameter, so it's more of a trapezoid. And so the math changes, and I'm not smart enough to figure out the math. And ChatGPT got me most of the way there, but it still wasn't right. So I'll make a post to the forum. If there's someone that's a lot more mathy than I am that could help out a little bit, that's the last thing that's getting in the way of me completing that. Because when the math's wrong, the head doesn't move right. So, all right. Yeah, he's over there. if you want to take a closer look.
Yeah, with the Stewart, or what they?
The Stewart platform, yep.
Yeah, wow, so you had to, you designed this?
Yeah, it's all my
A month
design.
ago or something?
Yeah, a few months ago, and it worked great when I started controlling it and the head wasn't moving the way I wanted it to. I realized that I didn't have the right math. The right math does exist. I've seen commercial Stewart platforms. I think Carl even posted one over the past couple of weeks where it has the platform has a lower radius than the base, so it has a tapered. But it's too far out of the realm of my expertise. So
because you modified it, the
Yeah.
original one, there's good.
yeah, I have the math for when it's a cylindrical arrangement where the radius of the base and the platform are the same radius or diameter.
Base and the,
Yeah, this one has a narrower top than a bottom,
oh,
so the math changes.
oh, I see, it's going, it's like a cone.
Yeah, yeah, a cone, exactly.
Uh,
So that's where I'm in with that, and is typically the case for my talks. How did I get into this mess that we're going to talk about this morning? I recently had to purchase a personal laptop, and I found one that I liked, and because I found a single post that someone had managed to get Linux on it, and after they had dropped the price a couple of times, I went ahead and pulled the trigger. Initially, I did a dual boot, like Jim does, kept Windows on as a safety net. And one of the first things that I ran into was what I'll just frame as some limitations of Ubuntu. Up to this point, I have been using an Ubuntu or Ubuntu derivative for probably 10 years now. I've come a long way, but with ROS standardizing on Ubuntu and Debian, that's pretty much what I was tied to. So Ubuntu first, and then Pop! OS caught my eye because of the way they handled window decorations. So it's Ubuntu in its heart, but a little bit prettier, but always Ubuntu. Now, what's great is that it's super stable, easy to use. The desktop environments are feature complete. However, when a new version of Ubuntu is released, and I always use the LTS versions, which are updated once every 2 years. And so right now, well, not right now, up until this past week, my home box was Pop! OS Ubuntu 2204, so 2022 April. As soon as they decide on a release, they freeze all the major versions of the kernel and the applications that are available in the software repository. And it's something that I've known for a little while. And it hasn't bothered me because if I needed something newer, you could always, like Zoom, for example, when you download Zoom, you download a deb file, so you don't use the one in the repository anymore. But as far as my laptop is concerned, the features that my laptop needed to support were only in a very recent versions of the Linux kernel. So that meant that Ubuntu was just out. I couldn't use it. And I was kind of bummed out because, I'm tied at the hip to ROS. And then I remembered this project and tooling that Brian's been using. And the magic is called Distrobox. Now, in no uncertain terms, Distrobox allows you to run any application from any Linux distribution in a container environment as a first-class citizen. So what does that mean? That means that I could, for example, keep running Ubuntu, except for the laptop thing. But then if I wanted to take advantage of the bleeding edge Arch user repository, the AUR, I could install applications from the AUR that appear in my start menu as if I installed them locally. It literally frees you and it separates your need from running applications with the Linux operating system that you've chosen. And so, because I'm now using this tool, I'm now free from being tied to Ubuntu for a couple of reasons. It kind of became open season, like what distributions are out there. So we'll get through my whirlwind of Linux distributions that I have tried over the past month. And there are, there are a couple. Yeah.
Why, what did you need the bleeding edge for the go-to?
Yeah, the laptop was announced late last year and it was available at the beginning of the year, but it required changes to the Linux kernel.
Oh,
Between the screens and the processor and the peripherals that were only available in 6.9, 6.10, and 6.11. And Ubuntu 24.04, I think is an earlier rev of 6.9. So I can't run, I have to run a more bleeding edge. So that's
a classic, you know, you gotta buy an older machine.
So as soon as a laptop, and laptop hardware is a lot more persnickety than desktop. So if you've got a laptop that is a year or two old, chances are it'll be supported very well in Ubuntu because of that feature freeze. So when I was running 2204 back at home, if I installed LibreOffice, that version of LibreOffice is 2 years old now because they freeze the major versions with the release, which is great from a stability standpoint. And you know, if you're installing it on a robot for ROS, then you're absolutely tied to Ubuntu. But in my case, I needed a bleeding edge one, and thanks to Distrobox, I can do everything that I need in ROS while running a whatever random. I use Arch, by the way. Linux distribution. So
the best of both worlds. Get your stable cross-compatible Ubuntu version.
Exactly.
Your bleeding edge
ability
to be compatible with your laptop.
Exactly. And so I'm going to show you exactly how that works out for me. For a Distrobox, it has a couple of different backends. I just use Docker. Docker's been on my radar for years. I've worked with other robot groups, and when Docker became popular, people attempted to Dockerize all the things. Docker is a lightweight sandboxed container that allows you to run code safely with minimal overhead by using the kernel and some of your OS stuff. I'm probably botching this. Michael, jump in if I'm getting some of this wrong. So it's a lot lighter than a full VM. And it does a lot of things that are really handy in commercial settings. So do any of you remember DLL hell? The time where when you installed something or installed a new library, that you were in danger of breaking other applications because the applications you had installed depend on specific versions of the library. So depending on how you updated, you could break something. It doesn't come up as much anymore. On Windows, they have a rather more complicated way of dealing with it. One of you, if you've used Conda or Anaconda, you've experienced this firsthand, virtualized Python environments to separate out the Python libraries so that your bleeding edge AI thingy doesn't step on something a little bit older. So the concept of DLL is something that we still work with every day. And Docker was one of the attempts to address that. So if you're running a company, a business with a software platform, Docker allowed you to take everything that the application needs and to kind of create a static copy of it and all the supporting libraries. And once you had that set up and you had that image set up, you could launch it. And then every time you launched it, it would have the exact same environment and setup. So from a stability and reliability, and it was super, super awesome. I worked with an InMove robot team who is Dockerizing some components of it. So there is a lot of uses for it. And there actually was or is a way to make your changes persistent. So if you wanted to log into a Docker container, you could make some changes, but it took extra work and it wasn't really easy. So I wasn't really doing much with it. So yeah.
And you probably know that licenses for Docker. We used to use Docker desktop Windows work, but we had to stop because they now charge a small license.
Oof.
So now we have to use Docker CP and Linux.
Okay. Wow.
So personal use, I think,
okay, but like business.
Yeah.
I don't think it's free. Or if you're willing to pay, yeah, it's reasonable, but it's not.
Yeah, okay, yeah, I wasn't tracking that, but it makes sense, right? Embrace, embrace, extend, extinguish. Yeah, so there's, so what Distrobox does, and it has several backends, it takes Docker and it exposes some of that advanced functionality in a way that works for you. So the stack that I want to get in front of you today is the backend, the rigging is Distrobox, which makes Docker containers extra useful in a desktop context, and a little GUI helper called BoxBuddy. Now, this is what I'm going to focus on. I don't think I'm going to have to look at the CLI, the bash commands for Distrobox, because you can do almost everything through the GUI. But man, this is super, super cool. Let me show you how cool it is. So we're going to, how cool is it? So, and I'll loop back to why I use Arch, by the way, towards the end. But in my laptop, I just have what's installed. The only things installed are what I need for the desktop. Every tool that that I need on it that isn't part of the OS or the display manager or the desktop environment, I have put into a Distrobox. So I have a Distrobox that I'm working on for Waydroid to have Android apps on here. I set up one for Olama to keep everything separate. KVM, Lidevert Vert Manager, I have one for that. And most importantly, I have one set up for tools. So anything that I need that isn't part of the OS, I install here.
So these, you can do all these on your regular system and then be able to run things that you need them at any time.
Exactly. So it keeps the entire install and all the dependencies and everything separate. And there are several different, each one of these is a different Linux distribution. I have an Ubuntu 24.04 one set up just for ROS. Tools is the one that I have set up, and I have Chrome installed on it, Visual Studio Code, anything that OBS, anything that I need installed, I'll install in this Distrobox, and it's totally separate from my core OS. And so even this web browser, this is just Chrome. This Chrome browser is hosted in my tools Distrobox. And so in that tools Distrobox, I have installed Visual Studio Code, OBS Video. And once I install it, I can add it to my start menu on the host.
So it's easy just to run any of these from your host, and it's seamless and brings up Windows, accesses the disk, everything.
Yeah, here, let me bring that back up. I accidentally closed it.
So the tool is like always running, or you have multiple things running at the same time, or do you turn them off and turn them on only when you need them?
So when you, it's a great question. When you boot up, all the Distrobox Docker containers are off. And then through the magic of BoxBuddy and Distrobox, when you add it to your start menu, the start menu exec command includes spooling up the container if it's not already up, and then launching the application from within it, and then it appears on your desktop. It is super slick. So when you go and, where's my so this is my start menu. We'll get back to why I use Arch, by the way, in a few minutes. So it shows up in your start menu with the name of the application and then where it's coming from. And so you launch it. The first time you launch it, it takes a few extra seconds to spool up the Distrobox container, but it's completely separate. The upgrades happen separately. So, aside from, the separation of concerns and stability, in spite of me using Arch, by the way, if you want to experiment, like if you see, like if you want to use something from the Arch user repository and you don't want to pollute the rest of your system, you can spool up a new Distrobox and give it a name. And just from the UI, you have access to a great many default images. So, and a lot of these, I don't even know what they are. Alma, Alpine, not sure, Amazon. You can spool up a new Distrobox, a Docker container with Arch, CentOS, even Clear Linux, Debian, Fedora, Mint, Kali, OpenSUSE. And so for example, if you wanted to spool up one for ROS, if you went off the deep end but still wanted to do ROS stuff, you could spool up a new container. 2404 doesn't show up quite yet, but I'm sure it will shortly. So you select your Docker container and hit create, and it generates that new Docker container with the image you selected. And once that's been generated, we'll select ROS for a second. Let's just open a terminal. So it opens up a terminal. I have a little bit of scriptery that indicates what prompt you're in, because you could bring up your prompt for any container that you use.
Self-identifying.
Yeah. So fast fetch. So my native container, the one I'm running on my host, Hyperland, the terminal emulator is Kitty, and I am using ZSH, right, instead of Bash, right? So this is what's on the host. The container that I opened for Ubuntu ROS is Bash. I don't know what this means. And it's Ubuntu. FastFetch identifies it as an Ubuntu distribution. So through a little bit of scriptery, let me close this one out. ROS2 topic list. ROS is running. So I'm running ROS in a Distrobox container from within Arch, by the way.
You had to install ROS. You had to spin up a new.
Exactly. Yep. Go through the standard ROS2 instructions to install it as if you were on a ROS distro. And so there's a little bit of script trickery that I want to show you, just because the terminals that you open in each container inherit everything in your home directory, including your startup scripts. Right, which is great. You can make that separate, but it actually comes more in handy than not. And so I did a little bit of scripting, because in this case, if it's the ROS container, I want to run that source opt ROS jazzy setup.bash, right? And I'll show you exactly how I did that in a, oh, we're running a little bit behind.
Right, you have to say, like, yeah, you have some conditionals in your bash RC saying.
Yeah, exactly.
If this distro or if that distro, then do something different.
Yep. So check this out, just to really drive the point home. The Chrome that you saw was run on tools. I'm in the ROS container, ROS2, run rviz2. And I'm running rviz in Arch through an Ubuntu 2404 container as if it's a native application.
Now, how does it actually, is it using X client, X server to do that? I mean, like, in other words, to bring up a GUI from one, system from another, it's usually an X client type situation.
Yeah, there's no slowdown. It's running, it appears to be running native speed. I don't know exactly how it does it, but there's not the slowdown from running through a dedicated VM with an emulated. Hey, come on in, you're just in time.
So it's sort of transparent to the user. Really.
Exactly. Yep.
My laptop's about to die. If I'm host, soon.
It'll close. Did you bring your charger? What kind of charger do you use? Is it USB-C? Okay, here, I got you. There we go. All right.
Right, so you just said, Ron, you're in your.
Yeah, so this is just
You're in your client here, or your, we're in your ROS, spin up, and then you
Mhm.
can run.
You can run any application. If it's a GUI or installed application, you also have the option to post that as being available on the host through the host start menu. If it's an installed application, yeah, like Zoom, for example, or Visual Studio Code was a little bit handy to have.
Oh, it's called it.
Yeah, yeah, and so you can make it available from your host start menu as if it's a installed first tier. So with the realization that this was a thing and the knowledge that I had to use a bleeding edge operating system, it ended up being open season for what do I want to install. Now, Ubuntu is near and dear to my heart. If you're using ROS, it's on a ROS robot and you need to use ROS, this is always your first choice. I was always very fond of Pop! OS. It just has a really nice desktop look to it that kept my eye for a long time. It's party. If you want to go to the parent of that, Debian, that's a very solid base. There's a reason that Ubuntu and everyone else is based on that. I started looking into Fedora. Fedora is more bleeding edge than Ubuntu. They tend to have more faster releases, and that was the first place that I looked. But what really caught my eye was a project called Fedora Silverblue. Fedora Silverblue is an official branch of Fedora. And this was actually installed on my laptop for about 2 weeks. And its claim to fame is that it's what they're calling an atomic desktop or an immutable desktop. And what that means is that as there's new versions of software and as there's new versions of the kernel or changes to the installed application, it takes a snapshot of your previous system before it upgrades. And yeah, it feels similar to that. Yeah. Yeah. Or a time machine on Linux. And so what's nice about this is that if you install something new and then you reboot and there's a problem, you just reboot and you select the previous snapshot. So you can try different variants. You can install an update. You can test install an application. And no matter what happens, aside from your laptop catching fire, if there's a problem, you can go right back and have a usable system. Full stop, no exceptions. Now, I'm not going to get involved in the super nerd discussion about whether it's truly an immutable desktop because your home directory is an immutable and because, you can have app images on there and that, no. Oh God, don't care. It's an immutable desktop. It's an atomic desktop. And honestly, I think this is going to be a lot more popular and is the future of Linux on the desktop, specifically because you have a wayback machine to go back if you do something that wasn't great. So I spent most of the time here, and I'd like to spend a couple of minutes showing you some of the cool things about that. Now, the only downside to that is there's two. The minor one is that whenever you install or remove applications, you're going to have to do a reboot because it's taking a snapshot before it applies it. So when you make a change, you've got to reboot to have the change. So that's a little bit of an inconvenience, but that's your trade-off for stability and security. The second one is that there is a way to layer additional applications on top, which I'll touch on briefly just to show you. But the entire application ecosystem in Fedora Silverblue is Flatpaks. So it's a containerized application that you download not only the application, but all of its supporting dependencies. There's Flatpaks. Ubuntu has Snaps, which is their version of it. App images, you might have downloaded once or twice. They all feel vaguely like containers or Dockers in that they're a self-contained application. And those you can install and uninstall all day because they're completely separate. Yeah, here, I've got a container running. Let's go full screen here. So So this is Fedora Silverblue 41 beta with all the eye candy and all the GNOME extensions set up. We'll just let it get acclimated there. Of course, video background, because why not? Now, there's a whole bunch of eye candy going on here. I think I'm gonna spare a few more minutes to go over this because this probably has a lot more impact to all y'all before I tell you how I ended up in Arch. By the way. So RPM, just like they have their own methods of maintaining software. Now in Silverblue, the magic command is RPM OS tree. And what this does is it tells you what version you're on, the previous backup. And I've overlaid a couple of applications that I just needed for functionality that can't be Flatpaks. So Distrobox we talked about, that has to be installed, BTOP, GNOME Themes Extra, GNOME Tweaks, LiveVirt for virtualization. So there is a method to install applications as an overlay through their repository. And then as you install them, takes a snapshot and you reboot, you're good to go. Same thing with OS updates. App updates will happen automatically in the background because they're app images, or no, I'm sorry, they're Flatpaks. So there's no need to reboot except when it updates the software center. Just a moment.
Flatpaks, it's like
It's a containerized application.
Separate, updated, it's independent. You don't have
Yeah.
to take a snapshot or review.
Yeah. So there's definitely opinions about which one's best. Personally, I wish that Ubuntu hadn't have gone with their own version of Snaps. They're the only ones that use it. Flatpaks are what everyone else seems to be using right now. And through Software Center, and I was going to show you there's some pending updates. When you say okay to that, it'll download and set them up. And then when you're okay to reboot, you reboot into the new revision of your OS with the application updates installed. So if I were to make one recommendation for anyone who wants to go off the reservation from Ubuntu, Fedora Silverblue was cool enough that I had it on my laptop for 2 weeks. And everything got set up. It was perfect. Let me just, so a couple of things in Ubuntu, if you're using Ubuntu and GNOME, is, okay, this is going to take a little bit longer than I wanted. But there is a whole series of user extensions that you can install that really take it up a notch. The Astra Monitor gives you a toolbar summary of what your computer is doing right now. And this is available as a GNOME extension. And it is super cool. Blur My Shell. Oh, sorry. Blur My Shell simply gives you a blurred background when you go to the applications menu. Burn My Windows. If you guys remember from the early days of Compies and 3D accelerated desktops in Linux, it was a wild time. So I'm going to switch over to those in a second. The caffeine extension. Yeah. Oh, we're going to do that in just a second. I'm going to. Compies. Yeah. Or Compiz. Yeah. COMPIZ. Yeah. So some of it survived, and I'll show you in a second. Caffeine, its function is very simple. When you click on it in your menu, it keeps your display from going to sleep with just a button. So if you're working and you know, you just, okay, perfect. Yeah. Open bar allows you to customize the look and feel of the different aspects of GNOME. Paper VM. So we're going to talk about tiling window managers in a second. And all this started with, once I knew that tiling window managers exist, I suddenly became annoyed with manually having to maximize and minimize windows. I'm too busy for that. Why should I have to maximize, minimize, or set them up? So what Paper VM does is it takes care of that for you. As you open up windows, it will stack them to the right, and you can still maximize them if you want. And It'll stack them left to right. It just automatically handles it in a way that you don't need to worry about where to put them. So for a laptop situation where the screen's still relatively small, this was amazing. And it takes a little bit getting used to, but I can't imagine operating GNOME without it. Tweaks and extensions in system menu. That just gives you these top bars of extra options. So extensions manager, GNOME tweaks, settings, a little nice to have. Whether or not is around here somewhere. And then there was one more. Oh yeah, and Hitamari, the video background was pretty cool. Yeah. So I just installed an extension manager, and these are the ones that I ended up on, which gave me a GNOME desktop that I was happy with. Super functional, enough eye candy for days. Hitamari is the video desktop background. So you can upload video clips and launch it at startup. Desktop, you get it for free. On laptop, there is an energy cost for that. So, but who can pass that up?
But this manager has to be in the snapshot, right?
Yeah, these are all snaps. Or sorry, I'm sorry. Forgive me. These are all flat packs.
This is.
Oh,
your
okay.
regular OS, so you're not in a container right now, are you?
This is well, this is I'm running it. This is a virtual instance of it, so I can show you guys. Because I do run Arch, by the way. And so the GNOME extensions are installed outside of the OS, so you don't have to reboot when you install them. So I grabbed the extension manager that allows you to install other extensions, and then just spent some time figuring out what worked and what didn't. So let me turn a lot of this stuff off so I can show you the other stuff.
When you install like this, the Flatpak stuff, is it transparent to you? Like you just find it, install it, and don't have to worry about. It'll tell you if you need to reboot or.
Yeah. The anything that you install out of system updates and that RPM OS tree command that I briefly touched on, those things require reboots. Anything that's Flatpak or a GNOME extension, you can do it all day because they're not part of the OS.
Okay, it's sort of like in a bunch of the software update or the software installer or whatever. Uses Snap, right? Okay.
So there's an option for the old school copies burn my windows, which is fun. There is, maybe some of the stuff may not work under virtualization. There's a desktop cube that I don't know if I can do under virtualization as well. Anyways, so yeah, so if I had one recommendation for something you want to seriously look at, if you feel that Distrobox has freed you from Ubuntu tyranny, Fedora Silverblue is a really compelling option. However, after having it up and stable and looking just like this and perfect for 2 weeks, something kept catching my eye as I was doing YouTube searches for desktop managers and stuff. And that was a really super awesome tiling display manager called Hyperland. And so let me get part 2 up. We'll make this, let's get rid of that. And that tiling display manager is primarily available on Arch. Getting back to my my summary, I still am in the camp of when in doubt, just don't. This isn't what I'm showing you next isn't something I'm recommending. but I do want to get on your radar to let you know that it exists, how it works, and what it does. And if this has really piqued your interest, I apologize in advance. But this is where I'm keeping my laptop now. And I just tried to reimage my desktop to Arch Hyperland. I've installed Arch Hyperland on my laptop in virtual or on the laptop hardware about 20 times to get it right. And I'm up to about 10 times on my desktop, and I still haven't figured out how to do it with RAID. I have 2 drives. So again, this isn't a recommendation. I just want to show you what it does. So there's a whole meme about Arch users being arrogant, and there's this quote that says, how can you tell if someone uses Arch? Don't worry, they'll tell you. So and it's just a meme. The guys are super cool. The forums are super helpful, but they are definitely a do-it-yourself kind of crew. Arch is an operating system made by and for people who know Linux. So there is no real automatic, sexy GUI installer with options. The Arch homepage is very helpful, but belies the nature of the operating system and its support. If you want to install it, you will boot to a DOS or to a prompt, and you will install it by hand. And each of these steps only gives you a hint of it. There is an Arch install script, which does work, and I did use. Unfortunately, it doesn't work with RAID arrays. But you're definitely not in Kansas anymore if you decide to go down this path. But if you do, you have access to a tiling window manager called Hyperland. Hyperland makes a lot of intelligent assumptions about how you want window management to work in a very good-looking, bleeding edge Wayland way. And it's what I've been using except for the VM. You'll notice that when I open up a window, it opens up full screen. If you need to open up another window like a command prompt, it's really big on keyboard shortcuts. Windows Enter brings up a DOS prompt, and then they'll share a window size. If this one's active and I open up another prompt, it'll open up another one down there, so on and so forth. Each one of these you can maximize if you need to get a better look. And then as you are finished with them, you're gonna let me do it? There we go. I had programs running on these, sorry. Yes, yes. You can just exit out of them. Getting back to my suddenly being annoyed about manually managing windows, this is like heaven for me once you get used to it. Now, this is all the sexy part of it. They have their own program for their title bar. They have their own program for their app menu selection. This is called Rofi or Wofi. The name of the bar is Waybar. I actually use a pre-configured desktop that someone else did called My Linux for Work, ML4W. It's a complete script to install Hyperland and its default set of tools on top of Arch command prompt. It makes a lot of assumptions about key bindings and how you want the windows to work. And anyone on Arch that you talk to will recommend that you not do this, that you install your own from scratch, which I respect. And this helped me to understand really quickly the difference between a tiling window manager and a desktop environment. When you install Ubuntu or Manjaro or Endeavor OS or Debian, you're installing usually GNOME or KDE Plasma or XFCE. It's a complete desktop environment. It's a window manager, and it's all the window dressings, how to manage networks, how to go to sleep, how to set up laptop settings. They've bundled all of these programs and features and settings into a desktop environment, so you don't have to figure out how to do that. When I first started working in Hyperland, I couldn't figure out why my battery was only lasting 2 hours. I'm like, that's strange. Under Fedora and under Windows, it was hours, hours and hours, and now it's 2 hours, full stop. That is because the power management programs and systems aren't installed, nothing's installed by default. So after I got TLP installed and configured and customized for this laptop, I'm now getting up to 11 hours again, but it's not in the box. So if you decide to toy with this, install it in a virtual machine first. Don't go full in to see how it works. Try it virtually, and then if you're, you move forward, stay on virtual for a while. The other thing is that where in a desktop environment, you will have all these settings and defaults set up for you. In Arch and in Hyperland, you configure it yourself, and you do that through what they affectionately call the dot files. It's manual configuration files. Hyperland's super smart. As you make a change to a Hyperland configuration file, as soon as you hit save, it evaluates it. And if there's an error, it ignores it. So that part's more real time. But every time I go in and do this, here's what I feel like.
Okay, let's go.
So that lives in my head rent free, and so now it does yours as well. So much so I set up a keyboard shortcut for it, so it comes up. Oh, play it again.
Okay, let's go.
So you're going to learn a lot about Linux and configuration files, and there's a lot of power in there, and you can download other people's dot files to customize it. And so what you're looking at now is my customization of his version, but it has been a rabbit hole to go through and set this up the way that I want to. You can, just like I said, you can maximize, you can also freeform. When you grab Windows, you hold down your hotkey and then you can grab it from anywhere, as well as resizing it.
Is the tiling window manager like similar to regular Ubuntu has the Windows key with the arrow keys and you can move things
Yeah,
around?
they've gotten
a
it.
more advanced version of
Yeah, and in Windows 11, you have a drag to the top to like preset stuff.
Double click the bar to maximize
Yeah.
vertically, but the biggest one is Windows key, or I don't know what they call it in Linux land, but it's a Windows key.
Yeah.
And then using the arrows, you can do all sorts of stuff, organizing. And
Yep.
there's more hidden ones.
Yeah,
like
yeah,
Windows
exactly. And then
key, Windows key plus some other letter. There's a lot of them. I don't even know them all.
Yep, and in Arch plus Hyperland, you're in total control. I've learned most of the shortcuts and setups from ML4W, so that's what I'll use forever. There's a few other desktops that just show off the beauty. It's all eye candy of it that you can use as a starting point. So if you decide to go down this path, absolutely install it in a virtual machine, and then just use one of the pre-configured setups to get your bearings. What they do is the custom desktops they call ricing. And so there's always competition. And if you're using a default off the shelf one, you're considered a noob, blah, blah, blah. With ML4W, his is almost a desktop environment. He's coded a settings app that gives you access to some appearance settings and wallpaper and systems. And you'll still be spending a lot of time in.
Okay, let's go.
But this is where I think I'm going to live for a little while. So naturally, because I'm not nearly as smart as I look, after spending 2 years in a safe, secure, fully containerized snapshot Fedora Silverblue system where everything worked perfectly, I went to the exact opposite, to a bleeding edge distribution which prides itself on giving you access to up to the minute. I can see that there's 4 updates available now. Up to the minute, and then I have my BoxBuddy for for everything else. So yeah, Distrobox plus BoxBuddy frees you up from being tied to a specific OS. Definitely, if this piques your interest, take the time to see what else is out there. Archcraft is a version of Arch with a GUI installer with some really nice themes. Fedora Silverblue, Fedora, any one of the other derivatives. It's open season now. You can choose something that you like that resonates with you. And no matter what you choose, you still have access to all of the tools that you need.
So BoxBuddy, is that what we're seeing, that interface?
Yeah,
Talk
yeah.
about the Distrobox.
Yeah, there's Distrobox is a command line application, and
Right.
there are more options available there. But for most of your use cases, I would just work through BoxBuddy because it gives you 80% of the capabilities and options in a way that's easier to understand, especially if you're just starting out.
It seems,
Yeah.
Does Distrobox replace Docker, or is it the equivalent?
Distrobox is a layer on top of Docker. So you have to have Docker or Podman installed first, and then it'll leverage Docker. And then if you're doing through most distributions, it'll do that in the background. Distrobox gives you the wrappers to use Dockers in an interactive, persistent way, and some scripts that allow you to automate the availability of an application installed in the Docker container as an app on the host OS.
it's the bridge.
It's the bridge, yeah.
into your host.
Yeah, technically you could do everything with Docker without Distrobox by doing the scripting by hand, but Distrobox wraps it up in a nice, easy to use interface. It allows you to manage those features, and then BoxBuddy is the GUI on top of that, so you can manage it using your
It's a
mouse.
layered approach.
Yeah.
You made a reference to Arch Linux plus Hyperland.
Yeah. Yeah, so getting into the minutia, if you've been involved in Linux, you may be aware that over the past 10 years, there has been a steady migration from the GUI desktop that you use for Linux. The back end is called Xorg or X11 by Xorg. It's grown stale. The management and the committees of it haven't been keeping up with the times. And in frustration, a very smart individual whose name escapes me right now decided to reimagine that same graphical interface to your graphics card in the display called Wayland. And it's been in the works for at least 10 years. Just over the past year, most distributions have either provided a Wayland option or have moved to Wayland, like Fedora 41 is now Wayland exclusive. And it is a modern interface to your graphics card and your display. And
replaces Xorg.
it does. They still have an Xorg-like interface, and there's still a couple of bugs to work out, but not bugs, but features and stuff. But NVIDIA and AMD are super happy with it because they're able to implement new features faster. And Hyperland works on Wayland specifically. So the hidden middle layer between Arch and Hyperland is the new display manager called Wayland.
Yes, it's a display manager. It replaces the old one that have been around for almost 40 years.
Yeah, and it grew too stale and it was too hard to work with. They were too slow to implement new features. And so, and we see this all the time between OpenOffice and LibreOffice, and except those are forks. But if something doesn't fit the bill, someone else can come up and take up the slack. So
Wayland is, like it says here, Wayland is a communication protocol between the display server and the client. For 40 years, X or whatever, Dongle or Dick, some of those old applications like XIs or XI. I still use XI to see if it's working, but
yeah,
Wayland
is the new display manager that's replacing X11 for modern desktops. Yeah.
Well, finally, because it was very outdated, they said.
Yeah.
The old
Yep.
one.
And so the last thing is Hyperland has a lot of really great documentation, which is nice. They've got a wiki that's very well, and the thing is, you can run that predefined desktop environment out of the box, but you are going to have to get into, we're wrapping up.
Okay, let's go.
Big files if you want to first make it fun. So may this meme live forever rent-free in your head from this point forward. All right, so that's all I got.
Thank you,
All
Alan.
right, thank you.
And for those that weren't counting, he said, I use Arch, by the way, 11 times.
Oh, I was going for a full baker's dozen. Darn it. All right, next time.
All right, so Jim is up next, when he comes back.
All right, so we've got a couple of minutes.
Alan, I would like
Mhm.
to maybe wondering what laptop you ended up getting. Said you were shopping for a laptop.
Oh, yeah.
You got a real nice one.
So,
I'm looking
and,
at-
and my IT manager is sitting right behind you, so it's a little, so my, Walter was kind enough to give me a 16-inch laptop when it was time to refresh, and I absolutely loved it. And I thought I wanted a 17-inch laptop because I wanted screen for days. And after using it, I came to the realization that I needed a smaller laptop. And my last day is on campus is the 25th, so I have to give it back anyways. So after looking around to see what was out there, I was closely looking at a laptop called the Asus ZenBook Duo. They announced it last year, and it became available this year. So I window shopped over at Micro Center earlier in the month. And I'm like, you know what? That makes sense to me. It's got a 14-inch screen. And then if you need more screen real estate, you can unfurl it. And so I went and checked it out. I got hands on it and I'm like, this is my laptop, but I don't need to buy it yet. And then it kept dropping in price. I think because they're getting ready to release the future ones. So after it dropped in price twice, and knowing that I had to have my own laptop anyways, I went ahead and pulled the trigger on it. And it works, huh?
14 or
14s, yeah, it's got two 14s on it.
16?
Well, yeah, it's small enough to be portable for a single screen, but then if I need more screen real estate, I just take the keyboard off the bottom screen and set it up. And now I've got two 14-inch screens, which has been pretty awesome. Yeah.
Oh, it's.
Mhm. Yep.
Why do you take, oh, you mean to get more?
Yeah. So it's a standard laptop. It's just a little chunkier than a standard 14-inch. But I can always unfurl it when I need to, when I need more screen size. Windows 11 Home. And then I dual booted for about a week. And then I single booted for about 2 weeks in Fedora. And then I went full Arch. And there's a few things that the touchscreen on the bottom doesn't work very well. I had to write my own script to detect whether the keyboard was attached and to turn on and off the screens. It's not all roses, but once it's set up, I've been very happy with it. Yeah.
So that's, I have to check it out later.
Oh yeah, during break, I'd be happy to show you. It's
Nice to have that.
mhm. Yeah, for sure.
And it's what does it come with? Oh, what did you say about 12? You said your laptop lasts for 12 hours? Or?
Yeah, so I've run battery tests on it and
That's
in
this one.
yeah, and in typical single screen use cases like note taking and like light web, it's up to 11. But if I've got both screens up and I'm using all the cores and I'm doing something super nasty intense, it goes down to about 3.5. So in an extreme, 3.5 in an extreme case.
Oh, that's.
But for standard use, between 8 and 11. Yeah,
And what's the GPU? Does it have an NVIDIA GPU?
not just integrated. Yeah.
Okay. So, yeah, like our laptops and, RTX NVIDIA, they're gonna eat up a lot more battery.
So some of that eye candy then must be taken CPU.
Yeah, there is the video background eats up about 10%. So I have a keyboard shortcut set up to be able to turn it off when I want to. But yeah, because it's a Wayland first and GPU accelerated, it's actually I think demonstrably more efficient because it's able to offload more of the UI stuff off to the GPU instead. So yeah, so far so good. I've been very happy with it.
That's a deep dive into Linux. Yeah, but it's like, it's adjacent.
Robot adjacent, yeah.
It's adjacent because ROS depends.
Right. Everything runs on Linux,
Yeah,
right?
I'm gonna do my why Windows is the superior operating system lecture next month. Oh my God. Just kidding.
All right, whenever you're ready, Jim.
All right, well, hello. I am, I've been working for a while on my Truckosaurus robot over here that is a ROS robot and an outdoor robot, and it required knowing where it is and through both locally and globally, meaning GPS as well as its orientation and velocities. So I'm talking, so I have to get into MPUs and inertial measuring units and in order to know where the robot is, how it's moving. So I'm going to talk about my experiences with the famous, now kind of, it's sort of out of production, but the 9250 MPU 9 axis with orientation, acceleration, and the compass. And so I'm going to talk about that, and one of the key factors or key takeaways is going to be the calibration is key to success. So let's get into the hardware to start with. The MPU 9250 is this small board here, and it provides some really useful information to help realize where your robot is, and what forces are on it and how it's moving. Acceleration is the accelerometer, rotational velocity is the gyroscope, and the compass is your magnetometer points to Earth's magnetic field, allows it to, or makes it point to north, magnetic north. And these are all in X, Y, and Z, which you can kind of see here in this diagram, the directions of those three axes. Yeah, for most of this talk, or for all of this talk, it's going to be about a robot on the ground. So it's not a flying robot, so the Z is of less interest, except for the rotation. That's going to be your heading around the Z. But that's where the 9 comes from, is the X, Y, and Z in each of those. And with compass, you actually also have magnetic field in X, Y, and Z. It's mostly X, Y that matters. The Z sort of points into the Earth. Because it doesn't look like this actually. That's the accelerometer. This diagram is the accelerometer and the gyroscope. And the compass actually, the Z points down. But in any case, from these numbers, you're going to get more useful information. So here's what we're after, the situational awareness, I call it. Your robot is moving through the world. It's going to have the MPU, it's 9 axes. It helps us find the robot's situation. By situation, I mean pose and how it's moving. The pose is its XY coordinates. As you can see here, the robot is sitting there or it's moving. It's got a direction, it's moving in, it's got a position. So that's direction is heading, and the position is in XY. And also how it's moving, the velocity in X and Y, and the velocity in turning or heading. I should say velocity in, well, yeah, that. It's gamma, I think. and so the values from the NPU, help you get this information after some processing. And I'm not going to go too much into ROS in this talk, a little bit, but it's a little bit kind of a separate talk almost, because this is a lot more detailed. This talk we're focusing on the IMU itself, calibration, installation, configuring. But the bigger picture in ROS is that you have that IMU, you have a wheel encoder with your on your motors, and both of those all that information goes into processing to find your estimated 3D position and orientation. That's the pose. So this is sort of how things work in ROS is these two, at least these two sensing or sets of information go in and end up informing the system of this information, where you are, and actually also where you're going, or the direction you're going as well. So the first thing, so the story I have is, I first installed, I have this IMU, I know I need it. I initially started using, the base of the software I started using is called Dino Robot 2, both hardware and navigation GitHub, for instance, two different GitHubs. One's for the hardware, which is, by hardware they mean Arduino. So it's firmware that runs on an Arduino, and the Dino Robot 2 regular GitHub runs on the CPU for navigation and all of that stuff. So I decided initially to connect my IMU to the Arduino portion, the firmware, and connect it up to in this case, a Teensy. So as you can see over here, let's see. This is where IMU, this little box, this orange box is the IMU and all these pictures. So the first mistake I did, so this is part of the story, is I just installed the IMU in the most convenient mounting point in this kind of a very tight area inside this RC car. And later on, I realized how close it is to the main motor. And the first rule about IMUs is installing IMUs is keep them away from magnetic fields, mainly because of the compass, which is trying to measure the magnetic field. So motors, batteries, and permanent magnets. And in my wonderful story, I made each of those mistakes in that order: motor, batteries, and the permanent magnet, unintentionally. But the first was I installed it without really it being in a hurry to get ready for Robo Magellan. I just installed the IMU where it would fit, and then later I started running the motor, and I'm like, oh gosh, that's too close. And I made a video of this where I run the motor. It's on YouTube, where I show the output of the compass, and then I turn the motor on, and the compass goes crazy. So I let my mistake be a teachable moment. So I recorded a video before moving it. You could also, if you have no choice, you need multiple batteries and multiple motors, and like there is no place you can get far enough away, then you might consider new metal shielding, which is a picture of it over in the corner here. It looks like this. You can buy it. I have not tried this, And apparently, according to Sergey, one of our long-term members, it's kind of a bit of a voodoo art in order to place this shielding around to get it to work. It comes in sheets. It comes, yeah, it comes, I think it's stiffer, but, you can manipulate it. I think like tin foil or something like that. I have not bought it, but it is a way to try to shield, your sensitive devices from magnetic fields. I prefer, after hearing that it's a voodoo art, I would, and I don't know anyone who's shown, I've never seen an example of it in use, so I would try to avoid that unless it's like you have to. And there are other ways to get around at least magnetic fields that are constant but don't change with the calibration. We'll get into that in a minute. So my second attempt was I moved it next to the battery because again, it was convenient. In denial about what I had read really, maybe it won't matter. And I'm not sure if the battery mattered in this case, but something else, when I put the top down, maybe this coil of wires, I don't know, it caused some degree of problems. Plus I wasn't that happy with this off-center location. But it may have been battery, you know, because of the metal, the steel in the battery, there's also electric field as the current is drawn, which creates a magnetic field, and then that can cause problems. So finally I settled on this location in the third one here. And then, again, Sergey helped me out. He was like, you know those GPS antennas, they have a built-in permanent magnet for putting on top of your car or something. And I kind of forgot about it. And because it's very subtle. So I went underneath and tried to open this like kind of a gummy plastic bottom and then pulled out a permanent magnet. So that thing is now magnet free, but that may have been causing a problem. I mean, it's, you know, magnetic fields fall off with the square, one over the square of the distance, but I was having a problem where tilting the robot up or tilting the car, pitching up or down was causing the compass to move a lot. And maybe that was, it could have been, it still does it a little bit without the magnet, but it might have been part of the cause of why it was such a big deviation was this magnet. I'm not sure, but yeah, so that's the story about installing. And it is kind of hard because underneath where this is, there is a lithium ion main battery that I can't really get too far away from, but I think it's pretty, it seems pretty stable now, as much as I can, but, you know, again, I guess this is a trial and error of some sort, as long as, but yeah, if you know these things ahead of time and pay attention to them, then you can probably avoid as many moves. Any questions so far? So, what's in my robot, as far as electronics, we have microcontroller, and we have a CPU. The microcontroller is a Teensy, the CPU is a Raspberry Pi. The microcontroller, typically for wheel encoders and motor control. So this is the microcontroller on the right here, the Teensy. You want the, generally speaking, I've always, from this group and robot clubs, been taught that you want a microcontroller for signals such as, for clean signals, such as PWM, and general purpose IO that's producing waves, square waves, at a very, a consistent hardware level, you want your, a dedicated, microcontroller that isn't affected by a high-level operating system with many interrupts going on, and that can affect your I/O, which it does have. But it turns out my initial choice of connecting the Compass or the IMU to the microcontroller was not as warranted as I thought or needed. And in fact, it turns out that, well, I'll show you in a minute, that it's probably better to connect it, the IMU to the Raspberry Pi. So this is the breakdown into what they do. The CPU is used for localization, navigation, and control. These high-level processing functions and user input for control. Automation is what I'm talking about, autonomous control. So that user says go somewhere, and that has to come to the computer, and then these other things are going on, localization, etc. So the key thing to know here is the microcontroller has to connect to the computer via USB serial. So that's what this is sort of representing here, this line. And the raw sensor data is processed in the CPU to find the robot's pose and velocity. So,
do you have ROS running on the Raspberry Pi, or what software do you use?
Yeah, so,
Navigation control.
yeah, I'm sorry, I should have said this. I might be saying later, but the next slide. But this is a ROS robot. Yes, it was ROS. ROS is running on the Raspberry Pi, and it is handling localization, navigation on there. And in fact, on the microcontroller, it was running called micro-ROS. And micro-ROS is like a lightweight microcontroller version that can publish and subscribe essentially, just like ROS. One of the big, just for people that may not know or not as familiar, but the big advantage of ROS, or one of the big, I shouldn't say advantage, one of the big sort of aspects of it is the ability to publish information and subscribe to information. And so to receive information and to publish it on channels or topics, they call. And this is a way to communicate information such as sensor data, and also to control a motor by sending the other way. So it's a two-way communication in ROS. ROS has these topics. You can subscribe and you can publish. So in this case, the MC publishes information from whatever sensors are connected to it, and it receives information about how to move its motors from the CPU. So that's sort of the breakdown. And it has to go over USB serial, which is a limited amount of bandwidth. Okay, that's what's going to be critical, and why I ended up deciding to change where I plugged in the IMU. So here's the next slide about that. So where do you connect it with ROS? There's the ROS, and it's ROS 2. So connecting the NPU to the NC microcontroller, okay, it's fast and it's in C++, but has some issues. The frequency of updates is limited by the serial connection to the computer. Okay, and why is that important? We'll cover that in a minute. But in a CPU, for the CPU option, I'm saying it's possibly better, even if the control code is in Python, which
runs just fine, actually. The frequency of the updates can be much higher because the raw data is read over hardware I/O. In other words, like I²C, because in this case, the IMU is plugged into the Raspberry Pi, then the Raspberry Pi has an I²C hardware I/O, and that is not limited by the lower bandwidth of a serial connection. It's a very high speed, a relatively high speed connection directly to the CPU. So that from the I/O ports on the Raspberry Pi. So in this case, it's a possibly better choice. And in this case also, you do not have to worry about for instance, interrupt-based operating system that is Linux, because in this case, I²C or this raw data coming across is it's going to be, it's not relying on, you're not generating a signal like a square wave outputting, you're just receiving information. And so that's why it's fine to have this particular sensor information from using the Raspberry Pi I/O as opposed to the very dedicated MC hardware, which is better at generating signals without interruption.
Well, it makes sense that if it's directly connected to the CPU or the Raspberry Pi, it's going to be maybe a little bit quicker, but if you have a fast serial connection like 19200, I mean, how much data is being transferred back and forth?
Well,
Is there any lag?
yeah, we'll get to that in a minute. I'll tell you why. So the accuracy, this last point here, accuracy of the position and the velocity. So this information is critical for your system to predict and to calculate the position and the velocity of your robot. Okay, and this is done through something called robot localization, aka sensor fusion. And this, it performs better when the frequency of updates is higher. And we'll tell you just how high you need them. And in fact, the serial port, even at 19.2 or even 115,000, due to the amount of traffic, it may not be fast enough, really, for ideal use, or for best use, and best ability to localize accurately. So I guess, okay, we'll come back to that because I'm going into calibration first. So we'll come back to why that is. And I have an advanced slide actually, but so calibration, you need a driver that has calibration for all these components, all three components. The gyroscope, the accelerometer, and the compass, okay? And so I have two versions now. These are, I have a reference page at the end, and I'll share these slides to the mailing list. The superscripts refer to the references at the end of the talk. And so those are going to be URLs, so all of the URLs that you can click on to go to various websites, GitHubs, and you'll be able to see. So the Python version, so I have two, what I was talking about before, these two different situations of connecting to the Raspberry Pi or connecting the IMU to the microcontroller. You need your driver for both cases. The Python, for the Raspberry Pi, I have a Python driver. It has these routines to calibrate the different components. Calibrate gyro, accelerometer, and the compass. And the MCU version in C++ has the same thing. It's just one routine that's both in the first place. So you need this, and it's critical because when you have the, oh, this is an IMU I'm showing on my video screen. This is the actual, and I'll get into what this cube is. So you need to, when you buy this, it does have some factory built-in or factory saved calibration information in its ROM. However, that the compass doesn't have such a thing. It's not saved in there. And even the accelerometer and the gyroscope, the saved factory calibration is not always accurate enough. Once you install in your environment, when you have a separate IMU out in the open like this, the factory settings may in fact work fairly well. But when you install in an actual electronic rich environment like a robot, it is not always the case. This is a separate calibration cube where I'll show you. So I took the one in there out, put it in here, and used it to calibration. I'll show you that in a minute. But this, before you install your IMU in your robot, you'll have it out like this, and you'll do a particular procedure. Then you install it, and you take it out of this and install it permanently in your vehicle.
So it stores some settings. On the IMU, does it store settings?
Yeah, so, well, you can't save the settings permanently. There's no static RAM that you can write. There's no EEPROM that you'll write to. However, you end up saving the calibration to your disk, your hard drive, your non-volatile, your long-term storage, and then you you load your calibration.
Got it.
And now that's for some. For some things, as I'll tell you now, you calibrate every time you start up. So that's because some of it's easy. And in fact, here it is. Calibration routines can be called at startup. All right. The calibration of the gyroscope requires no movement for a couple of seconds. So gyroscopes have a certain amount of drift, whatever. And so when the IMU is sitting, not moving, and you take a bunch of measurements, you'll see these drift. And then what happened during this calibration at startup, it just has to stay steady for a few seconds. Data is collected by this routine, and then it's averaged, and then that goes into a value that then is used every time you grab a gyroscope readings, it subtracts out those offsets, right? So the offsets are calculated to make it all zeros when it's sitting still. So when it's sitting still, any number that's not zero is wrong, really. So this thing takes those measurements and then gets an average and subtracts that for all future readings. So then when the thing is still, it will come up zero. And so that's your first one. Now that can be done at startup. It only takes a second, and it can be in any position as long as it's still, because gyroscope measures change in angular position. So if it's still relative to the Earth, actually even relative to anything, then that's fine. Then it figures those numbers out, saves them, and then you're fine from then on. However, calibration of the accelerometer, this is all using the routines that I told you about. So the calibration of the accelerometer using the software that we have requires the orientation to be perfectly flat to the ground. And like using a bubble level has to be perfectly flat. Now, problem for an installed MPU in a robot, because you look at this robot, you know, it's never exactly level to the ground. The reason that is that you need that is because you need gravity to be perfectly down for this calibration routine to function as it's designed. It's a very simple piece of software, or it needs to have some way, it needs some sort of constant to be able to calibrate. We know gravity is a constant, okay, 9.8 meters per second squared, straight into the center of the earth. Okay, but if you're tilted even a little bit, you're not going to get 9.8 meters per second squared. And the reason you need that is, since that's the only known thing, that's the known acceleration, that's known when you're on the earth anyway. And so, since that's the one known thing we have, we can, you can orient the, if you are perfectly flat to the ground, then you can measure how far off you are from 9.8 meters per second when you read back the value of the particular accelerometer direction, say Z, that's going into the ground. So that's, so, and in fact, I'll show you what this is for, is to actually change where gravity, change the orientation of the sensor into multiple positions and test using gravity as the constant, and therefore checking all of the directional, the X, Y, and Z sensors of the accelerometer against gravity. And therefore, you can figure out how far off it is from each one. Unfortunately, you can't do that when it's installed in a robot, because it's just too practically impossible to get it perfectly level in 6 different orientations. But you can do it if it's outside the robot in a cube like this. And I'll talk about that in a minute. Yeah, I'll pass this around actually, both of those. So, what am I doing? Calibration of the compass takes about 20 seconds, and you need to rotate the sensor in all axes like a figure 8, just like you've probably seen it on your phone when you have to do the figure 8, except in the robot, ideally you want to rotate it completely around in 3-dimensional figure 8, so that what this is doing, this is let me say first, this is a slight to big inconvenience depending on the size of the robot. And you should do it whenever the robot is modified, like the interior, or it's been moved to a new location. And so what this does is that when the routine, when you set it, I want to calibrate the compass, you run the compass routine, you then rotate this thing in all directions in a figure 8. What it's doing is it's taking all that data in many times a second, and then it's finding the extents, the boundaries of the full extent of that data, like all of the maxes and the mins, and therefore it's figuring out what kind of sphere of information are you in the magnetic sensing are you getting? What are the extents of that sphere? And that's how it calibrates the compass. So it knows the max magnetic strength and the min magnetic strength in all directions. And then it will calibrate that. Then it multiplies and offsets that to cover all directions. If it's it'll detect if it's off. If it's not the full range, it will provide a multiplier and an offset value that will make it into a full range.
So you talk about how you initiate this calibration with a push button or something?
Yeah, but now it's I can show. I kind of want to do a demo too. Essentially you run a routine from the command line, and it will then say, now I will show you
So
that.
they're connected with your laptop.
Yeah, you connect, oh, I need to do this up with my demo. So what happens is, once you connect and everything, you run a routine, it says then, okay, calibrating compass, please rotate in the figure 8, and then you do that, it captures the values and then saves it. And it also does the gyroscope as well. That one just like takes a second. Yeah, you can pass this around. So now, now I'm into this slide is talking about dealing with the problem. So I addressed the compass and the gyroscope, but the accelerometer I haven't addressed. That's what this is for. So to do the accelerometer, you can do a one-time for each physical IMU you have. You can do a one-time accelerometer calibration using a level to make a level surface. And I have this wonderful, it's a flash cube for a camera, but it acts very well it acts as a very good level in 3 dimensions, so that you generally get a table and you put that thing on the table, and then you, if it's not perfectly level, you put some pieces of paper and make a little wedge or whatever, and then so that you can, however you can use just paper and fold it, whatever you need to do to make the bubble centered in all directions. Then you can use that as your surface for using this calibration cube. Okay, so there's a video at the end of this talk, number 5. You basically run a program with, so you have this cube with the IMU in it. You have a Arduino, or the Raspberry Pi alone. You run this software, another script, Python, and it will ask you to, you have the level surface, and what you do is you follow its directions. It will say, okay, start with the cube flat on the ground, and then after it'll say, okay, after a certain number of seconds, rotate it 90 degrees this way, 90 degrees the other way. So basically you're doing all 6 different orientations of that cube. And each time it's measuring that sensor, one of the sensors, against gravity. One of the directions. It's the same sensor. It's all the accelerometer, but it's accelerometer in X, and then Y, and then Z. And then negative X, Y, and Z is upside down in each of those. Once you've done that, it's collected enough information now that it knows how far off the accelerometer is from ideal constant of gravity. And you've made sure that through your level that you're as close as possible to actually physically oriented directly towards the downward, towards in the gravity direction for the center of the earth. So this information then gets saved in a file, bunch of numbers, and that is a permanent. You don't have to do that again. You should not have to do that again for that sensor. Now the last thing here is that if the robot is small enough, you can do on-demand compass calibration, and which logs to the user. And then I actually take this robot and I do move it around like that because it's small enough. If you had a tractor trailer like this, you can't do. You can imagine, doing a figure 8 of a tractor trailer. It's not going to happen. So it's unlucky in this case. For those cases, you may have to have a way of taking out the compass from the tractor trailer and calibrating it, by hand that way. But in the case where it's a small robot, you can move it around. And yeah, I'm going to get to a demo in a minute. After that, you need to test results. So I'll show you a routine where print out the values, roll, pitch, and yaw. I guess I didn't fully mention, but the raw data from the IMU goes to the robot localization, which is part of ROS. And so from those 9 values, you get things, some of the values you get out are the roll, pitch, and yaw, which is the angular orientation of the robot. And yaw in this case is the compass direction. So it's the global direction. And pitch and roll are the orientation of the robot on its own axis. And you can see this is what, so this is good. This is a good start to print out. And you can see these numbers move when you're rotating. But even better is an RViz plugin that shows you a visual representation, so you can really see if it's working. So let me get that demo running here. So let me log into the So I have to change my home configuration. Hash. Log in. So here's the first one. Let's see. Can I link this quickly? So it loaded the calibration from a file, right? And now it's printing out. There you can see it printing out. I'll close this for now. So when I move the robot, you see yaw is changing quite a bit as I do this.
Yaw the compass.
Yeah, oh, there's a discontinuity there. I might have not printed that right, but. And then pitch, you can see pitch is pitch up and down. That pitch is along the x-axis or the y-axis. Y-axis is from my left to my right. So as I move up and down, the nose up and down, you see pitch moves, and then roll is the last one. Now, so that's a decent way to check values, but what's even better is if you use RViz, right? So this routine here, I'm running a script that just runs the MPU alone, and it loads see it's loading calibration file there. This doesn't run all of my other robot stuff, but it's at least it's just to test it's just the IMU portion. RViz 2, and then so we bring this up now. We can open an IMU visualization we have here. So this is what I wanted to show you. I love the graphical stuff. Oh, and then let's move this to a slightly better view. So I have this sort of representation of my robot, a very crude cube, and that big vector is the gravity going downward. So as I move it, you can see where I'm pointing is changing. I can actually do it so it's in the same direction as where I'm really pointing, I guess, relative to this room. So you can see as I point, it's going left, I'm left, and then I go right, right. If I tilt up, tilts down, and roll even works. So now you see it's always going to be a little shaky because there's, well, I'm not perfectly still, but also there's noise in the readings. Now with the compass, it was noisier than this, and I am applying what's called an exponential weighted averaging, which all it really means is you add in, you take an average of the incoming value. It's an ongoing average, a weighted average, and each time a new value comes in, you only bring that in a fraction of that value in as part of the average. So like 10% of the new value plus 90% of all the old values.
Yeah, I was gonna ask you, because if you just take a single reading, you might get yourself in trouble.
Yeah, I mean, you can do it. It's just a bunch. I ended up not liking because it was just too jittery. But a weighted average, it's called exponential because of it gets diminishingly as you get further on. It's diminishes as an exponentially as you go into the future. So as opposed to another kind of average is like a window average where you have an array of say not 20 values and you just shift in the old ones. So that's a non-exponential or linear average. This is exponential because it's only 10% of the new one plus 90% of all the old averages from the current running average. So okay, so that's hopefully that impresses you a little bit. It took a lot of time, a lot of effort to get to that point. Now the next slide. So that's testing. Now for any question, or actually you had a question. So some advanced information about this. To achieve a stable and accurate filtering, which means that's what we're doing. The localization is this filtering of the IMU information. The sampling frequency should be at least 5 to 10 times the frequency of the dynamics of your system. That's a fancy way of saying, in every, like you need some rate of update to handle how fast things are moving or changing movement. And with humans and robots of hobby use, about 50 hertz is typical or suitable. So you might want to update your motors at 50 times a second, right? And you might want to find out where you are 50 times a second, up to around that. So as you're moving, like you're driving a robot quickly through a park, you want to know, like, as it's moving, 1 meter a second or something, or up to, say, pretty fast, you may want to have about 50 hertz, up to a point. There's always a range. If you're a jet fighter going at that speed of sound, you probably need a lot higher than 50 hertz. So in that case, the IMU sampling should be 250 to 500 hertz. I don't even know if I'm going to be able to achieve. I doubt I'll be able to achieve that, but that's what the real expert recommendation is, that you need 5 to 10 times frequency of your system. So if you try to do 250 hertz of through a USB of this message with those 9 numbers, along with other data that you're doing as well along that bus, because that bus is shared with all the messages going both ways, then you're going to be, it's going to start filling up there's some buffering at either end. Serial is the serial USB serial is going to be a bottleneck at some point. That's going to stop you from doing 500 hertz, times, these values coming in, these messages, and there's overhead. So I haven't gone far enough to, prove all this yet, but I ended up moving my IMU to the CPU, and Sergey also influenced my opinions.
Yeah.
He has the same opinion.
Where is your sensor actually monitor position?
Oh, this is it right here. So the IMU is here, in the middle, about, outside the robot. I don't know if people saw the picture, but if anybody online, it's the orange rectangular box there.
And what's inside that?
That's the IMU 9250. That's this IMU here. This one right there.
Oh, that chip and actually now they're inside that.
Yeah, so that's in there. And this is kind of what, how are we on time? Okay, we're pretty much to the Q&A. So here are my references. There's a nice general overview of getting started with IMUs and the ROS driver in Python, and which is built upon this bridge between the MPU and the ArcPy. And then IMU tools, these are very useful, including that visualization that I just showed you, plugin for RBIS, and then a driver in C++ for the MC, which is still could be useful. And I have a modification so that it doesn't do you can turn off the acceleration calibration, which requires it to be perfectly level. So I turn that off because I'm not ever going to use that. I do the cube method. And then this is a calibration cube video for what exactly that procedure that you do and rotate and run the software and then it writes out the info.
Yeah.
So that's the end of that. But yes.
I'll take questions. You separate your sensor from your truck, so to speak.
Well, it's, I mean, I have not gotten blue metal yet, but
Oh, that's what I was asking.
I've not, now, I didn't get into it to the detail of the compass calibration, but when you run this calibration and I can show you, I end up doing this whole thing with whatever when I run it. It calculates what's called hard iron and soft iron, the calibration. And the hard iron is like the magnetic environment that it's in, that's permanent, right? And then the soft iron is like the offset of or the soft iron is the non-permanent, sort of in, like, so there's these two aspects, and you can read more about that. I mean, if you want more detail about how those calibrate, but essentially it's, when you look at the three spheres of X, Y, and Z, the spheres of data will be displaced from each other. So the hard iron brings them with the same center, and then soft iron tries to scale them to be the same. But essentially, that you're trying to, this calibration does that by collecting all the extent, lots of readings and the extent, and then calculating the scale and offset for it in a nutshell.
I have a question. Some of these MPUs, I know that they come with two sets of pins that you can solder. Some that you can put it like a 90-degree angle, some flat. Is there a particular use for when you want it flat or when you want it at a 90-degree?
Oh, you mean for like these here? Like
Yeah, the connecting pins. That must have come with two sets, like mine, the one I use.
Oh, it came with like a 90-degree.
Yeah.
Yeah, I mean, I assume that's for convenience for mounting.
But,
I don't know.
I think you still want it flat, but it's just a matter of where you want it.
yeah, you're right. It seems like you want it flat, yeah.
You probably want it as flat as you can.
Flat, yeah.
And so, however, I mean, some people mount them. You're right. You can mount it any way you want, really. Yeah, I mean, I wouldn't mount it, like this. That would just add to your. That would add to your like calculation, your math, math problems, but but yeah, mounting like
and then mounted, like I had mine for a long time like this, instead of like it is now.
That's the other thing, yeah.
But I just, I used that RViz and I saw where's the front of the robot pointing, and it was off by 90. So then I just rotated this, because, my last iteration, I went through all this difficult, I had it the other way, because I wanted the Y direction, of the accelerometer, or to be like what Ross expects. And in this, what's fascinating, or what's interesting about this is the IMU and the compass are in different coordinates. I don't know why, I guess it's just kind of the nature of it, where one of them is called NED, northeast down, and the other one is ENU, east, north, up. So, NED is like this, north, east, down, and then ENU is like this. So in this device, the compass's axis is different from the accelerometer gyroscope, which are the same. And so I was going through gymnastics to get
For
that.
your application, are you just complex, or you're using?
I would use all of them, yeah. I mean, mainly the compass and the, for now, it's mainly the compass, but.
Right.
But you just feed those into Ross, and then Ross does everything else.
Yeah, well, that's another talk, the robot localization and the EKF, the extended common filter processing, there's a local one and a global one, and, both. But yeah, you feed it into there, and, the accelerometer, that information it helps in the localizing, because the data is taken in by this localizer and it predicts. It has an internal model where it's predicting, and then it gets the sensor information coming from the real sensors, and then it tries to match or adjust its prediction. That's sort of how it works. And you can configure it to use all or none or any individually which values that it's going to use in that prediction calculation. So for instance, mostly like for right now, I'm not really using the accelerometer much. I'm using that mainly the compass, the direction. But I eventually want to use other things, because you want to know like how fast you're. I'm gonna have real encoders, but real encoders are subject to error, and so you also want the gyroscope and.
I'm thinking if you're navigating in terrains, maybe you could adjust this. For other things.
Yeah, now, for instance, I'm doing that, but the winner of the Robo Magellan for a few years now, Nathan, he uses just the gyroscope. He doesn't use a compass. So he points his robot due north at boot up, so that the gyroscope is 0 for north, and then he keeps track of the gyroscope. He keeps track from then on using the gyro.
So it could drift over time.
Yeah, but
Errors could creep in.
it does. It can creep in, but he's
Well, because
managed.
he uses the camera.
Yeah, he also, I'm sorry, GPS. Don't forget.
Oh, yeah,
GPS.
right.
It's that, so that the gyroscope may drift, but the GPS will give you a position where you are. And then the robot will just turn to find a cone, with its camera. So even if it may be pointing in the wrong, it may not know where it is, it may be pointing in the wrong direction, but it's programmed to do a circle when it gets to the GPS coordinate, and then it looks until it sees the cone, right? So even if the gyro drifted, the GPS coordinate system, the GPS is working, right? Where it says, hey, you're still need to go east, northwest, no, east, northeast. So again, you have to using multiple sensors together. But for the local, there's both like I said, a local and a global. The global one uses
the IMU plus GPS. The local one uses no GPS, just the IMU and the wheel encoders.
And different, yeah, there's at least 3 ways of.
Oh. 3 ways of what?
Solving the whole, the way to navigate.
Right, yeah,
The right direction.
yeah, because you do want to still calibrate all this and, I mean, because the accelerometer and the gyro are very useful for knowing it when you need to know your acceleration or your position locally without GPS or,
I was wondering, you
Well,
talked
that-
about position, was reference like your starting point? Or,
yeah, the global position is, global, is in the world, like GPS coordinates. And the
And we are back from lunch. Oh, I forgot to ask, does anybody have show and tells? So I can add it to the list.
Yeah, I got one.
I did, yeah. All right, so Alan, I heard Alan first. I'll go later. Jim, second. Online, if you guys have any show and tells that you would like to present, let me know and I'll add you to the list. With that, Alan, go for it.
All right, just a moment. So many buttons, so little time. Okay. All right, let's move this over to 3. Okay, so just a little bit of errata about my talk this morning. One of the things that I mentioned is in Distrobox and BoxBuddy, when you're opening up bash prompts or zish prompts or fish prompts or whatever, it uses the existing .bashrc and ZSHRC from your host, which can be a mixed blessing. And there's ways of setting up your distro boxes to use their own home directory if you need to. That's when you'll create them using the command line. But what I wanted to share with you is how I use and abuse the bashrc system to be able to do things specifically for my distro box instances and not have it muck up when I just pull open a regular command prompt, right? Because things like ROS, you want to source the ROS installation directory, right? And normally we stuff that in .bashrc. In Fedora and Arch, by the way, it's set up a little bit more comprehensively and differently. But it's the same idea. If I just drop a source off ROS setup in my bashrc, then whether I pull open my ROS prompt or the host prompt, it wouldn't work for the host, right? So if you do a detection for a environment variable called container ID, you can conditionally do stuff. And this is, so what I've done is, first off, if I'm in a Distrobox bash prompt, I want to know. So I've got this really simple, hey, if container ID contains a value, then display the name of that container ID and container detected. So if I, for example, we'll do ROS, because that's what I brought up. Maybe that was a bad example. Let's do tools. For my tools box, my toolbox, there we go. Tools container detected. For my dedicated distro box for, what is this? Fusion 360 on Linux? I have a little note that Fusion container detected, and so you can see where all that magic happens here. Here's where I'll list the name of the container, so there's no confusion on my side what kind of prompt I'm in. And then if it's my Fusion container, I export a line prefix, and then I export an alias to just quick launch Fusion. And then oops, wrong button. And then in addition to that, I hand coded a desktop shortcut to launch Fusion. So on the Distrobox side, very simple thing to do. ChatGPT knows all about it if you need any help. And the last thing that I wanted to show you is, and I've been trying to do this on and off for years, and I've only gotten it to work once. There's a guy out there that, bless him, maintains a GitHub with a series of scripts that allow you to run Fusion 360 on Windows under Wine. And I've only gotten it to work once. I hadn't gotten it to work since. Even under Fedora Silverblue or Fedora, I couldn't get it to work until very recently. But so one of the benefits of rolling release distribution, like later Fedora or Archer, another one, is that you always have access to the latest and greatest executables, including Wine. So just because of that happenstance, I am able to run Fusion 360 on Linux as a first tier application. And it takes twice as long to open up, and it takes twice as long to open up a file, but it works, and it works very well. It's almost perfect. There's a little bit of a glitch. This panel, which you remember being transparent, is not. And when you right click, let's let it adjust. It's doing something right now. When you right click, you have to bring forward that context menu. Oh, no, I don't want to do that. Okay. So when you right click, you just have to left click and hold to bring it forward. So I'm calling this 100% usable and super awesome. And so in my situation, this is the only thing out of Windows that I must have. I paid for a subscription. It's one of the few things that, oh yeah, literally brings me joy. Like I truly, huh? Yeah. So I truly enjoy the art of design and creation. And so with this, I still have a Windows virtual machine under Virt Manager that I have access to. Fusion 360 also runs on it, but it's super, super slow. So yeah, this is my icing on top, my cherry on top, icing on the cake, is I can use Fusion in Linux as a native application, and with a little bit of desktop application trickery, I even have an icon that I can launch it from.
Wait, so how does, I'm sorry, this is not, it's basically a Linux version that, you got from, oh.
Yeah, so there's a Windows emulation subsystem that's been available for a long time, and it's in constant development.
That's the.
Steam has a version of it, and so there's a lot of active interest called Wine.
Wine's been around
Wine is
for-
not an emulator thing, yeah.
It's not an emulator?
Well, that's actually what it stands for. It's
Wine is not an emulator.
yeah. And over the past couple of years, it's seen a lot of love. And this guy, Crinkly Fly, maintains a series of scripts that automate setting it up and getting it installed.
Oh, so it's.
Yeah. So that handles
a
the.
little effort.
Yeah, no, it is a little bit of effort, but
So the Fusion 360 is Windows application, but you don't have, is your Windows in another virtual machine?
well, I do also have Windows installed in a virtual machine, but this is a native install of Fusion 360 in Wine.
So when you're making projects next, will you be using it on there? Will you make whatever project you do next, will you be doing it in here like?
Yeah. So I have no reason, with this, I have no reason to boot back into Windows. So there's no Windows partition anymore.
So the application files is on your Linux file system? Okay, and then Wine just runs it?
Yep.
Oh,
How does wine do all that? I mean, it's been around for years, but it's not a actual virtual machine. So it's got a lot of libraries.
Yeah, so they emulate enough of the Windows subsystems and libraries to be able to run Windows applications.
Probably just a port of the Win32 API.
Yeah.
But I mean, the actual binary that you're using is well.
It's a Windows executable.
Windows executable. So
How did you get those installed on your Linux file system?
So there is a,
Is it part of Wine?
It's,
You had to deinstall 360 at all. Yeah. Because you can't do it from the Fusion 360, website.
The installer, unless you have
They don't have a, they don't have a Linux.
There's no Linux version. They
Yeah,
don't
but he
support it.
already had it, right?
In his GitHub.
yeah, so there's a curl execute
That's
bash.
why it's not a Linux version, it's the Windows.
It's a Windows version, and he
You have to
goes through
download.
the whole process of installing Wine, downloading the installer, setting up the Wine tricks to make it compatible. And so he's done all the hard work. All I have to do is basically click on it. And so he sets up all of that stuff in a script. And then that gives you an Autodesk launcher SH file. And then I went a step further and then created a desktop file for my applications folder so I could just click on something.
Yeah, that makes sense. Yeah. Wow, that's going through a lot of hoops to terminate Windows from your like.
But yeah, it's
I still have my Google.
yeah, I know, and I'm hassling you a little bit, but like you have to do what you have to do. Like for me, I don't use Office. Like everything that I do is Google-fied, and this was the only thing in Windows that I needed Windows for. So now I'm like, I'm out.
Oh, I see, yeah. I started using LibreDesk just because I don't want to do PowerPoint and then have to switch. It's like Linux is kind of pulls you in if you're
Yeah.
working on ROS or something, and then you're like, well, I need to do a presentation.
LibreOffice is just as good as Microsoft.
Yeah, and I used to like Microsoft a lot for their Microsoft Office. for,
Yeah,
in
and-
Windows.
And for those of you who have already dipped your toes in it, so I've got on my tools Distrobox, I have the entire LibreOffice suite.
Oh, I see.
And there is a setting, gee, I'll remember where it is, to give you more of a ribbon bar feel to more closely match the more recent Office versions, which makes it a little bit more comfortable. So it defaults to legacy.
When you save a file, is it still gonna be docked? or-
It'll say its default is LibreOffice native, but you can save it. There is an exporter to
Maybe
save
you
it.
can email it to someone.
And you can open up, Word files as
So
well.
what did you just do? You had the
Yeah, there's,
menu?
I can't, I'm trying to remember where it is. Under settings, you can change the behavior, the look and feel, and there's an option for a ribbon bar that more closely approximates the more recent version of Office.
Their Excel.
Oh, I didn't like that new version. I had to like begrudgingly get used to it.
Oh, okay. Yeah, so they have the legacy one as well.
But now I'm probably used to it going back.
So,
Yeah,
yeah.
LibreOffice seems, it's really evolved over the years. Like I was in Linux in the early 2000s or late 90s, whatever, and it's kind of crappy software.
Yeah, and if you don't want to install anything,
Yeah. Like the first one.
I figured, yeah, that might be.
yeah, and then even beyond that, if you're already a Google person, docs, sheets, slides,
I
and
haven't been into those so much.
Oh, yeah.
You like it a
Yeah.
lot? Cause it's online, right?
yeah, it's online. I think they have an offline component, I'm not sure, but it's kind of like WordPad Plus. It doesn't have all the features
Oh, it's like.
of it, but yeah, so they've got sheets, and for a while I was doing the backdrop for the Riverside Club using Google Slides.
Slides as good as. the
Yeah, so it's kind of like, the,
Presentation.
mhm.
Probably.
I just haven't got into
Transition
that.
effects and all that.
I sort of have some sort of distaste for online apps. Just something doesn't,
Now, I think
well, like-
Microsoft is now Microsoft 365.
oh, that, well, but.
The one thing I like about that
I
though
just
is
don't like
I
online.
use it for Word a lot, and it's like, I don't have to, if I stationary on my computer, and then I move my computer.
Yeah,
I can't control it, it's all saved.
Work is,
Never
like,
ending.
I use Confluence or whatever and those
Me
things.
too.
But, yeah, for work, but when you're like making a Word file or a PowerPoint, yeah, I just like it on.
Yeah, it's
I
the
don't want
right tool for the job. I can't knock anyone
You
else.
can download
I
the
don't want
file,
the.
like every file you do. you
Yeah.
download it on your desktop.
But I'll tell you, one
I
of
like
the,
offline processing.
case internet is down or whatever too.
Yeah, for sure. One of the main draws to the Google version of these is that there is live collaboration.
Yes.
So
Live, like,
the Unitree, or not Unitree, God help us, the guys that we're cracking the dog with, so they have an Excel sheet with status and updates and stuff. And so like, or imagine you're a college student working on a paper, like there's all kinds of use cases where you may want to collaborate remotely. And in that case, Google Sheets has been one of the best.
Yeah.
Not even Microsoft Online allows simultaneously editing.
you mean like you can see the other person change
Yeah.
the thing?
Exactly.
So I use that.
Yep.
Document.
Yeah,
Yeah, so what you do, and it'll show.
Instead of having to merge later and.
yeah, you can collaborate.
You can see their
It shows what cell he's writing in, and I can see, and then it'll pop up when. he
Yeah, there's
hits
like a little
enter.
screen pop in a different color if you're both editing the same
Yeah, yeah,
doc.
it's awesome.
Google Doc?
Yeah,
really easy.
yeah, you get that for free with Google Docs. So
That's a big, like, technical achievement then, with,
Yeah.
what's gonna happen to Microsoft?
Oh, here, let me unpin you, Jim. Sorry about that.
I'll actually, you're next though, so.
Okay.
There you go.
So, first I wanted to, first show and tell is, for the makersfaire. I'll pass around, how useful it is. Well, you can pass around this thing. You haven't seen it. And the makersfaire, brochure, here, you can pass that around. So I did end up going on Sunday after our meeting weekend. That was last month. It was a pretty good show. I did talk to Ethan, our friend Ethan, Fulton, and with some big 3D printers. And Vasily's, this one is the famous upside down printing portable 3D printer. Very cool. It's this one here, positron. Pretty neat. I mean, it goes upside down, has certain advantages. It's a very small platform. It's been out for a few years. It was featured in the magazine. The plate moves up and the thing is upside down. So anyway, but it has fewer problems with the gravity causing bulging and that sort of thing. You have to have good adherence or adhesive quality, but it does, produce better prints in some situations. This was Vasily's multi-tool device. It can change heads and this was built from I think
It's not only colors, it's
it's
different types of.
different types of material.
It's pretty amazing.
Yeah, you should help me out here, because it's different materials and different heads, and it could combine them,
Yeah. It's
right? Even like it can weave together, like PET G plus, some other, like, ABS together, isn't that where, because
It's something like
it
that.
does it in a way, I mean, not that, I guess it does it in a way that's interwoven, right? It's not like if you just do a layer of ABS and then try to do a layer on top of PET or whatever, it wouldn't bind, right? But this one, it's not for just layer, it's actually maybe it's more interwoven or something, like it changes, is that?
That, I don't know.
Would you know?
I don't know.
I forget, but otherwise, because why would you want to change materials in the middle? I think he told me it somehow,
Certain pieces need more flex to them.
yeah, but I think it's mechanically doing it so that, mechanically interweaving, maybe that was it. So it's not binding the ABS to the PET G, it's just building it around each other. Something like that.
Interlock.
Yeah, maybe interlocking. I can't remember. I'll have to ask.
And then they had another machine that just, like not different materials, but different colors.
Yeah, different colors. And that's NMU,
Yeah.
which I could even buy for my printer. Oh, I was gonna talk, anyway, so another big thing I liked was the Ghostbusters guys were there. I wish Walter could stay, but you probably know. These guys were right across from the R2D2 club, which Walter was supposed to be there, but I guess he didn't
couldn't make it. But they have these really cool packs. I don't know if I did the video, but the thing would like overload, break down, and then this little puff of smoke comes out, and it was like flavored smoke from a tobacco version. Yeah, or maybe from a vaping, flavored, not actually tobacco, but like one of those non-tobacco. But it was funny, yeah. I'm a big fan of these